Hello and welcome to today's screencast. The focus is on recovery from exercise. Now, when we are talking about recovery within physiology and A-level PE, we have to use a specific abbreviation. Now, the abbreviation is EPOC here, but EPOC is really important we understand what it stands for. So EPOC refers to excess post-exercise oxygen consumption. Okay, that's what EPOC will stand for. Now, let me try and put that into an example you might be able to, I suppose, get meaning from. So if you think about this, you go out for a run, okay? You play a football, hockey, netball game, whatever your sport is. When you do that, okay, you are working at a relatively high intensity, okay, which means it's quite hard to get the oxygen in you want to, okay. As soon as you stop exercising, okay, you will go from high intensity to no or low intensity. Now, when your intensity switches from high to low or no intensity, this then means that oxygen can flood into your body. Okay, and when it floods into your body via your lungs, your alveoli, etc., okay, this allows us to recover our body to its pre-exercise state. Okay, so when we think about this, let's have a look. If you want to write a basic description of what this is, you could put it as follows here. Excess post-exercise oxygen consumption, or EPOC, refers to using the extra oxygen available following exercise to aid recovery. Okay, so if we want to just have a quick look and see this in a graph, you will recognize the shape of the graph because we've looked at exercise graphs before, both in heart rate, stroke volume, cardiac output, minute ventilation, tidal volume, etc. You've seen them a number of times. So if I look onto here, you've got, if we go across the bottom, I think that's most important to start with. Before exercise, we've got rest here, okay? Following rest, we've got exercise, and then we've got recovery at this section. Now, I'm not too bothered about this. We'll come back to this when we look at another section. But this is just looking at the shape of the oxygen consumption. Now, if I just get you over to what we're really interested in today, okay, we are interested in this idea of EPOC. So as you can see, we've called this graph, or this kind of double change at the end of exercise, recovery in earlier parts of the course. Now we have to refer to it as EPOC. Now, what you will see here in EPOC is that there are two red arrows coming up from here, or two red lines. Now, these red lines are to symbolise the fact that EPOC is split into two separate components. Now, the first part of EPOC is called fast EPOC, okay? And fast EPOC can also be referred to as alactacid recovery, okay? So you can just put that in your notes. We'll come back to that in a lesson. So fast EPOC is what you really need to know, okay? Now, fast EPOC basically refers to the recovery that takes place in the first 3 minutes after exercise. As you can see here, it's the fast EPOC section here. Then the second component of EPOC is called the slow EPOC. Okay, so slow EPOC can also be called the lactacid recovery, and in this case, this EPOC, slow EPOC, takes from an hour up to about an hour to 24 hours maximum to recover the key things it needs to recover. Okay, so slow EPOC, hour to 24 hours. It starts, of course, at the same time, but it takes longer to carry out its functions. So on that term, functions, obviously, what you're going to have to be able to do in the exam is be able to explain the functions of fast EPOC and slow EPOC. So just to start with, I'm going to give you a very, very, very brief generalized kind of function of each of fast and slow EPOC. So if we have a look at fast EPOC here, its key role really is to recover the physiological components of the body, okay, the things that are depleted when we exercise, and then we have slow EPOC that has a specific function of removing waste products or harmful byproducts, and then allowing our body to get back to normal. So, like I said, that's pretty generic, okay, at the moment. So this slide is really important because it's a scene setter. It allows you to start off what we're going to look at, and then the next couple of slides are optional with regard to note taking. Okay, I would hope you'd want to take them, just because it gives you maybe a more thorough understanding. But they are optional. What is absolutely vital is that you listen through the full slide before you do make notes if you decide to. Okay, so let's have a look through onto here. So I've talked about physiological components of the body. So at the moment, we basically got this idea of it. EPOC, recovery. Recovery, or EPOC, is split into two. Fast EPOC, slow EPOC. We know that fast EPOC is recovering physiological components, slow EPOC is removing waste products. What do I mean by that? So what I'm going to do now is show you some physiological measurements during, or I think a better way to think of this is right at the end of an exercise session. So when you're just finishing an exercise session, what is happening? What are the physiological measurements going to be? So I'm going to put them down onto here. So the key physiological measurements we need to have an understanding of are, and you should start to recognize these terms from earlier in the course. So you've got PC stores. Okay, as you can see, at the end of an exercise session, your PC stores are low. Okay, ATP stores, low. Oxyhemoglobin stores, low. Oxymyoglobin stores, low. Glycogen stores, low. Lactic acid stores, high. Okay, so you could start to see, I'm sure you could start to understand this. So because you're exercising, we've depleted our PC, we've depleted our ATP. The oxygen from our hemoglobin has gone, so it's low. Oxymyoglobin, the oxygen has gone off the myoglobin into the muscle, that's low. Glycogen has been used for energy, that's low. And then lactic acid, of course, is high because we're working at an intensity that's causing it to build up. Okay, so that is an example of our physiological measurements during exercise. Now, what I wanted to just show you, and the reason why I said don't make any notes at the moment, okay, so just make sure you've listened to it all. When we are looking at fast and slow EPOC, fast EPOC has specific functions of recovering PC, ATP, oxyhemoglobin, oxymyoglobin, whereas slow EPOC has the function of recovering or replenishing our glycogen stores and removing lactic acid. That is the key focus. Now, what we are going to look at in today's screencast specifically is fast EPOC. Okay, so we're going to have a look at fast EPOC and these key components here. So if we're going to do that, I think it's important that we just kind of try and, I suppose, go back to what we've studied earlier in the year and just start to make sure we understand why these measurements are so low. So if we consider when we're exercising, we should know that PC stores are going to be low because we use PC for energy. So we know that PC is broken down by creatine kinase, which leads us P plus C plus E. Again, these are optional notes, okay? Don't make them until you finish the slide. Okay, so PC broken down by creatine kinase, P plus C plus E. Okay, so what we need to remember is that because we use the energy when PC is broken down, we're actually left with P plus C, okay, which is not useful for us, okay, because if that's where we're left, it means our PC store's low is because it's been broken down completely and the energy's been used. Same thing with ATP. We know when we're exercising that ATP is broken down by the enzyme ATPase, and that leaves us with ATP plus P plus E. So once the energy is used during exercise, we are actually left with ADP plus P. Now we will know that ATP is the only usable energy source, so the reason why it's low on this measurement is because we're left with ADP plus P. It's low because it's not there. And then if we look at oxyhemoglobin and oxymyoglobin, the reason why they're low is the oxygen has been used. So it's not on hemoglobin and myoglobin anymore. So that they're actually, so our blood then is just hemoglobin without oxygen bound to it, which means we can't use it to transfer oxygen towards our muscles. And then on top of that, oxymyoglobin, so the myoglobin, remember, in our muscle, okay, the thing that's protein that's responsible for transporting oxygen to our muscles is now just myoglobin because there's no oxygen left because we're exercising. So we're still at the end of this exercise. So now what we need to have a look at then, if this is what we're left in, the state we're left in, these kind of in the boxes here, we've only got P plus C, we've only got ADP plus P, we've only got hemoglobin, we've only got myoglobin when we're at the end of our exercise. What we need to do now is have an understanding that fast EPOC, the key function of fast EPOC, is going to be restore these components, okay? And what we're going to look at now is specifically how this happens. So let's have a look onto here then. So we'll set it up in this way. So your notes are, you have to do these now. Compulsory note taking, really, really important. So if we go onto here, fast EPOC, recovering the fuels of the body. Let's have a look. So we need to know what's recovered first, how does it happen, and then how long does it take. So if we have a look at this first up, you will, from what we just looked at on the other slide, the first thing we need to recover is ATP and PC stores. So in order to understand how it happens, we have to know this. So we've looked at, what it was and what we need to go. Now this is the real, I suppose, technical detail you need to understand. So in order to recover ATP and PC stores, we need to use endothermic reactions. Now, if you remember, endothermic reactions are those reactions that use energy to rebuild smaller elements into a larger molecule. So could you add this for me, please? Okay, so using energy from the aerobic system. Now, obviously, when you stop exercise and the intensity lowers and oxygen floods in, that is considered using the aerobic system, okay, because we're using oxygen, okay. So energy, endothermic reactions using energy from the aerobic system. Now, what we need to know now is how specifically then is energy used via endothermic reactions to get PC and ATP back. So let's have a look. So if we look at ATP first, we've got to use the E that we have now because we've started recovery, plus, that's the energy, plus P plus ADP equals ATP. Okay, now hopefully you can see how that works. That should be relatively straightforward. So because we're recovering, we're using the energy we now have, plus the spare phosphate, plus the ADP to equal ATP. And exactly the same situation or system works for PC. I said on the previous slide, because we've used our PC, okay, we're left with P plus C. So because now we've finished and we're in recovery, we have energy which can be used to put together, so E plus P plus C equals PC. So that then allows us to get back those PC stores that were depleted on the previous slide, or in real terms during when we're exercising at high intensity. Now, last thing we have to have a look at with regard to this, so we know we have to recover ATP and PC stores. This is how it happens. Now we need to understand how long it takes. And when we're considering how long it takes, we need to specifically consider the following. Okay, so in order, and we have to only talk about PC on this, in order to get PC back, or 50% of our PC back, it takes 30 seconds. Okay, so 50% of the PC stores we have in our body can be done really quickly in 30 seconds. But in order to get 100% of our PC stores back, okay, it takes 3 minutes. Okay, so 3 minutes, the whole of fast EPOC is the time required, 3 minutes, in order to get our 100% of PC recovered. Okay, now the second thing we have to have a look at is as follows. Okay, we need to know that, obviously, from the previous slide, if you remember, we need to think about how we get oxygen back to our blood and our muscles. Okay, so we then need to, the second part of fast EPOC is referring to hemoglobin and myoglobin. Okay, so this should be relatively straightforward. Okay, so in order, so we need to recover, the second thing, hemoglobin and myoglobin are recovered because we need to get them back to what they were. Okay, and we need to understand how it happens. Hemoglobin and myoglobin are no good for us in terms of being able to recover our body. We need oxygen. But before we talk about just the basic process of oxygen joining hemoglobin and myoglobin, we need to know how much. Okay, so during fast EPOC, we use 1 to 4 litres of oxygen, okay, from within the excess post-exercise oxygen consumption. 1 to 4 litres of oxygen is taken in, and from that 1 to 4 litres of oxygen, we join oxygen to hemoglobin to form oxyhemoglobin, and then we join oxygen to myoglobin to form oxymyoglobin. Now, this, in terms of how long it takes, we have to separate it. So oxy, if we consider now, we know from gaseous exchange that, when we come down, the oxygen comes in, it goes from the alveoli into the blood. So that's oxyhemoglobin. And then once it goes from the blood, it then goes into the muscles, which will be oxymyoglobin. So that makes sense, that it's going to mean that oxygen plus hemoglobin to form oxyhemoglobin is going to take 1 minute, less time, whereas oxymyoglobin is going to take 3 minutes in order to fully restore itself to what it was pre-exercise. So as you can see, the structure is pretty much the same. 2 things need to be recovered, okay, or 2 parts need to be recovered. We need to know how it happens, how long it takes, and that is basically what we are looking at with fast EPOC in terms of recovering the fuels or physiological components within our body. Okay, so that's that. So what I'm going to ask you to do now, final task really, is make sure you've got those in. It is absolutely huge that you made very, very specific, numerous Cornell note questions, okay, because this is tricky. So it's really important that you get this right and get the terminology correct. Now, just to go back to what we looked at before, if we consider now we have just completed fast EPOC, what would our body look like after 3 minutes? Okay, well, let's have a look here. So physiological measurements 3 minutes after exercise, as you can see now. This is not specific, of course. I'm not giving you specific physiological numbers, but I'm just saying at the end of fast EPOC, you would have a high PC stores, you'd have high ATP stores, you'd have high oxyhemoglobin, you'd have high oxymyoglobin, because you've had the 3 minutes. What you have to understand is specifically how these happen and the processes behind them. Okay, so what needs to be recovered, how does it happen, how long does it take for each of them? Okay, and that's what you're looking to be able to do. Okay, make good notes. Thanks very much.